All right, mini lesson number 3. Let's talk inequalities. We're going to solve them and graph them. When you have an inequality that says negative 2 is less than x plus 6 and x plus 6 is less than or equal to 9, it's pretty straightforward. You can go ahead and solve this kind of everything once at a time. As long as you subtract 6 to all of the terms, you're going to get negative 8 is less than x is less than or equal to 3. And then to graph that, I'm going to start at negative 8. I'm just going to label this pretty lazily. Negative 8 is going to be an open circle, and positive 3 is going to be a closed circle because it can actually equal 3. And since it's an and, the numbers that are greater than negative 8 and less than or equal to 3 are between here, so we shade in the middle. Those, I think, are the easy ones. When you get to the or statement, you got to be a little more careful. You still got two inequalities, and to solve them, you're going to add 1 to both sides. So x is less than or equal to 0, or when you add 1 over here, you've got x is greater than 7. So now if I have a dot at 0 and I have another dot at 7, less than or equal to 0, well, that's a closed circle, and the numbers that are less than 0 are going to go this way, or x is greater than 7, strictly greater than 7, open circle, shade to the right. So you have two different types of inequalities here. Sometimes you shade in between them, sometimes you shade away. It depends if it's and or. And the same thing happens with inequalities with absolute value. These are pretty tricky. When you've got a problem like this is saying that the absolute value of 2x plus 1 is less than 5. So let's think about that. Negative 5 to 5. This is the range of numbers that we want to actually use. But this doesn't graph x, this graphs 2x plus 1. But this is going to look like an and statement, so I can write this as negative 5 is less than 2x plus 1 without the absolute value is less than 5. Because the range of values that make this true are between negative 5 and 5. Now I'm going to have to solve it for x and actually graph that on my line, so I'll do this like I did before, negative 1 to everything, and now I have negative 6 is less than 2x is less than 4, and then when I divide everything by 2, I get negative 3 is less than x is less than 2 when you divide every term by 2. Now to graph that, I'm going to put it out at negative 3, and I'm going to put it out at positive 2, and these are both strictly less than, and since it's an and statement, I'm going to shade in between them. So when it's a less than problem in an absolute value, it's going to look like an and problem. The way we read that is and. When it's a greater than, it's a little bit different. It's going to look like an or problem. Because if you think about this, the numbers that have an absolute value greater than 7, well, these numbers all have an absolute value greater than 7 this way, but if it's going to be an absolute value is greater than 7, that means negative 7. We're going to go off the other way too. So we're not going to shade in between them. We're going to have to split this up into two inequalities. And the way we're going to do that is say either 2x minus 3 is less than negative 7, which means we're going off this way to the left, or 2x minus 3 is greater than positive 7. And when you solve these equations, 2x is less than, add 3 to both sides, divide both sides by 2, x is less than negative 2, or when you add 3 to both sides over here, you get 10, and that means that x is greater than 5. So x could be less than negative 2, or x could be greater than 5, so this is 5, and this is negative 2. They're both open circles, and here, greater than 5 shade off this way, and less than negative 2 shade off this way, and now we've got absolute value inequalities and absolute value inequalities.